Hello everyone, in this video we're going to go over the first part of the exam review. So in the true-false section we do have a couple of statements and then we gotta answer if they are true or false. So in this particular set of 11 true or false statements, we're only going to have one real false statement, which is this one. 1 plus tangent square of pi over 4 is equals to secant of pi over 4. Why is this false? Well, it's because it's missing one of the main details of the identity. If you remember the identity that we get from sine over sine squared plus cosine squared equals 1 is that 1 plus tangent square of x is equals to secant square of x. So the only problem is that this doesn't have the secant square. If this will have the square, it will be okay. But because it doesn't, then that's the reason why it's false. Now, otherwise, most of these statements are true. For example, the period of the secant function is 2 pi, and this the period of the tangent function, it is pi. So as I was mentioning, sine of x, cosine of x, and their corresponding functions cosecant of x, which are the 1 over sine is cosecant, 1 over cosine is secant. So just because they're all coming from cosine and sine, then their period is going to be 2 pi. The only two functions that they have a different period is tangent of x and cotangent of x, which they have a period of pi. If you remember, and let me go ahead and actually pull Desmos calculator. When we're looking for tangent of x, we got this function. And so if we're looking for a single domain, and then to check where all the other domain repeats, you can see that we can take this one. And this is going from minus pi over 2 to pi over 2. This is the domain that we have. And so that covers completely in a spectrum of pi. So if you measure how much there is between pi half to pi half, then that's going to be pi. Now for cotangent, we have a similar situation. Cotangent of x and let me remove this one. And cotangent of x, as you can see, it doesn't use the same domain. We're actually using for cotangent the 0 to pi domain. And why? Because cotangent is cosine over sine. So the 0, the asymptotes of cotangent are determined by the zeros of sine function, which are going to occur in the 0 and pi points. Okay? So that's also distance pi. And if you remember, then when we consider sine of x, you can go ahead and do cosecant of x. And you notice that, yeah, we do have 0 to 2 pi period for the sine of x function. And let me copy this so you can see more clearly the domains. Here we have a full domain of the function sine of x, and here we're going to have a full domain of the function cosecant of x. So as you can see from then removing those domains, everything else is just a repetition of these values. And the fact that the values here of cosecant of x go up to infinity, and we have more than once, is why it's so much more easier to actually solve equations using the sine of x than using the cosecant of x. Now, a similar case or a similar thing is going to occur with the cosine. With the cosine, we can establish the secant. And so, secant of x. So now you can see also how between 0 and 2 pi we cover completely one turnaround of the cosine, and you can see also how the secant function is working in here. Of course, you can move around some of these domains. So if you want to check, let's say minus pi to pi, this will also move around how the behavior of this is, but it's still going to be a reflection of the cosine functions for the secant function. So you can see cosine, secant, sine, and cosecants, they all have period of 2 pi completely, but tangent and cotangent, they have a period of pi. So that's why we can answer question 7 and question 11 as an affirmative. From the same thing that we just saw here, notice that cosecant has actually an asymptote here at 0, and it actually has an asymptote at pi and 2 pi. That comes from the fact that has to do with the sign. So the line x equals 0 is an asymptote, it's a vertical asymptote for cosecant of x is true. Now, from the same definition, you can see that sine of 53 being 1 cosine of cosecant of 53 is true as well. And this is just a matter of definition. So if you recall, the cosecant of x is just going to be 1 over sine of x. And so we can just flip this around, and then sine of x is going to be 1 over cosecant of x. And so thanks to that, sine of 53 will be 1 over cosecant of 53. Okay, so that makes this true. Let me complete this number 8. We have that tangent times cosine is equals sine of theta. So this is an identity, and we're trying to establish if that identity is true. And in this scenario, it is true because if you start from tangent times cosine, just let me look for a way to move this a little bit. So we have tangent of theta times cosine of theta. We'll start from there. We can then break apart tangent as sine of theta over cosine of theta. And so now you can see that when we simplify, we can cancel the cosines, and we're just going to obtain sine of theta. So that will make this one true. All right. Now, let's go for question number 2. And question number 2 says, let theta be the angle with the positive part of the x-axis and the line connecting the point 815. So what is going on in there? And I'm going to erase this here to give me some space. What is happening here is that we have an x and y axis, and we're considering the point 815. So 8, let's say, is here, and let's say 15 is here. So we have the point 815. And now we have the line connecting the origin and the x-axis. So we have a line that is connecting this. And we care about this angle. So you can easily see that we can create a right triangle here, right? And so if we measure this right triangle, well, this distance is going to be 15, and this distance here is going to be 8. And so using just the identity of the tangent, tangent is, remember, opposite over adjacent. And the opposite side to the angle in this case is 15, and the adjacent side of the angle is 8. So it is going to be 15 over 8. And so that is why number 2 is true. All right. So now question 4. Never mind. Question. Yeah. Let me go with question 3 now. This is also true. It says the law of cosine is used to solve a triangle of 3 known sides but unknown angle. So this is true. Did you remember this? One of the formulas of the Cosine's law. You have this. And so notice that if you know no angle, but you know all the sides, you know this, you know this, you know this, you know this, and you know this, you're going to find a number, and you're going to be able to find out what the cosine value is. So this is a squared minus b squared minus c squared over minus 2vc will be the cosine of the angle. And so in this way, you're going to find that alpha is sine to the -1 of a squared minus b squared minus c squared over minus 2vc. So you can get the information of every single one of the angles just doing this. I just use one of them, the one in terms of a and alpha, but I can certainly use the one in terms of b and beta and c and gamma, and just find all the angles. All right, so let's go to question number 4, but I'm going to erase the board over here to give me some space. Now, this is asking the exact value of tangent of 240 is square root of 3. So the easiest way to go about doing this is go to your calculator, plug what is the tangent of 240, and write a number. And then later write square root of 3 in your calculator and see if the number is the same. If the number is the same, you're done. And in this case, that's what's going to happen. So you can see that here from the calculator. So if you can get the calculator. Okay, I'm gonna do tangent of 240. And I think I need to fix this 2 degrees. No, these are the graph variants over here. Okay, never mind. Okay, here we go. Degrees is here. Okay, so according to this, tangent of 240 degrees is going to be 1.7. And if I go now and do a square root of 3, I get the same number. So in that way, and this you can do in your calculator, then you're going to find out that they're the same. That's just one way to go about it. But the other way that you can go about this is writing this is sine of 240 degrees over cosine of 240 degrees. Now, if you think of this in the axis, notice this is the 0 angle, this is the 90 angle, or yeah, 90. Let me write that in degrees instead of radians. So 90, 180, and 270. So 240 is going to be over here. And this is the full angle that I'm trying to find. But again, it's much more easier to find information in terms of sine and cosine, and I can find the reference angle. So if I use information on the reference angle with the quadrants, it's going to be much more easier. So instead, I'm going to find this angle here. And you say, how do I find that angle? Well, that's going to be easy. I just need to do the angle minus 180, as you can see from taking the two different angles to find the difference. And so 180 270 minus 180, 240. 240 minus 180. And that's going to give me 60. And so this means that I can use the reference angle 60 with the information of the sine and cosine here. So this will be in the third quadrant, the x is negative and y is negative. So this means that this is going to be minus sine of 60 degrees minus cosine of 60 degrees. The minus and minus is going to go away, and I'm only going to care about the value of sine of 60. Now, if you remember your unit circle units, sine of 60 is going to be square root of 3 over 2, and cosine of 60 is just going to be 1/2. So if you remember your special angles, then you're also done here. You can simplify, and you're going to find out that this is a square root of 3. So this is a much more longer approach to solving this question, but it involves more knowledge of your geometry of the unit circle, which can be useful in other cases that are not that immediately, or if you don't have a calculator in hand. Now, number 6, let's do number 6. Number 6 is also true. And for number 6, we're just checking that secant of pi over 6 is equals to cosecant of pi over 3. And you might be wondering, why is this true? Well, this is true because this is saying that essentially 1 over cosine of pi over 6 is equals to 1 over sine of pi over 3. And if we flip this around, this is essentially saying sine of pi over 3, which is a square root of 3 over 2, because we just saw that sine of 6 is that, is equals to cosine of pi over 6, cosine of 30. And then again, if you remember your special angles, then you know that this is true. And if you're not, you can use your calculator to check if the sine of pi over 3 is equals to the cosine of pi over 6, if it produces the same number. And so in this case, it is going to produce the same number, and this is true. Now, the last question that we have available here for the true and false is the ambiguous case of the law of the sine when the two sides and the when two sides and the non-include angle of a triangle are given? And the answer is yes. That is exactly when the ambiguous sides occur. Remember, and now that we complete our table, let me move down below. If we have a law of the sines, we essentially have a triangle. And from that triangle, we can be given some information. In this scenario, they're giving me two values. Let's say they're giving me A and they're giving me B. And I'm going to get one of the angles. B equals, let's say, I got this one 30, I got this one 10, and I got this one 5. And I don't have any more information. So I need to find the other angle. I need to find alpha, and I don't know the side C or the angle rho. So to be able to establish any meaningful information, then I gotta do the ratio A over sine of alpha with the one that has full information, which is B over sine of beta, so 10 over sine of 30. And when I'm solving this, you can see this is A equals 5. This is 5 sine of 30 over 10 equals sine of alpha. And so notice that here we have two sides and one angle. So every time that we're getting to find the angle, because we don't have two angles, then it's very likely that we're going to get an ambiguous case. Why does the ambiguous case occur? The ambiguous case occur because when we do sine to the minus 1, this is going to be a positive number, by the way. And I'm going to explain in a second why it's a positive number. So remember that we have the unit circle, right? And so sine is, we have coordinates here in the unit circle. X and y are associated with cosine of theta, sine of theta for any of the angles. So, and in this case will be cosine of alpha, sine of alpha. So if sine of alpha is, let's say, a number C, if C is negative, it means that I'm taking values of y down here. But that means that I'm either going to find this angle over here, or my second choice will be finding this angle over here, where will give me this. Both of these angles are bigger than 180. So in this case, if C is less than 0, alpha is bigger than 180 degrees. So that means no triangle, because this is going to produce, this is just going to produce something that it won't give me access to a triangle. Triangles have 180 degrees inside of the triangle. So alpha plus beta plus gamma should add up to 180. If the angle is already 180, so it won't work. So it cannot be negative. This number here cannot be negative. So now let's assume that the number is positive. So if sine of alpha is equals some C bigger than 0, then instead we're in the upper cases. And so we have this angle here, which is my theta 1 or my alpha 1, right? And we have one second angle that can be with this one. Right. Okay, so this is my positive number, and here we have from here to here my first angle, and then I'm gonna have from here to here my second angle. Okay, so either I have this one or I have this one. These are the two possible angles that I have. So the first alpha one, the red one, is just my reference angle. And the second one is just going to be pi minus the reference angle, or 180 minus the reference angle. So it is going to be an ambiguous case because I might have two triangles. I might have one or two triangles. The case where I have one single triangle is when one of the two angles is going to break the triangle. So adding to 30 is not going to leave me space for a third angle. Let's say, for example, if I do 155 degrees, added with beta, that's more than 180 degrees. I don't have a triangle at all. So likely I'm just going to have one single of the angles that is less than 90, and that's going to allow me to do one triangle. So that's the case. But it might happen that these two angles are both good enough so that I can create two triangles. And so that is when we have the two triangles, and that's why this is an ambiguous case, because it can provide me with one or two triangles. All right, next I'm going to be moving to the multiple selection. So see